All right. Number 12. Oh.
Like, I didn't do 12. I put a question mark. Somebody's not good. Can you do like 3 or 4 and try to do it algebraically?
Yeah. Okay. I'm having trouble. Yeah. All right.
I can help you.
Let me talk about 12 because I'm on 12 wavelength right now. 12 is an integer function. 12 should have been one of the must-know functions that you learned in pre-cal, but if you didn't, okay. It says to find the limit as x approaches 1/2 of integer x. Integer. All right, so let's see. I'm trying to think. They normally would do it rounds.
You just plug in the limit, right?
Yes. Do you remember those? Do you remember that function? Okay. All right. So the integer function is the greatest integer. And so what it does is it takes any number and it actually, I'm trying to think what the, I hate this function. It's going to round it. It's going to round it down to the nearest integer. Okay, so in other words, if x is 1/2, what's the closest integer below that? 0. So the integer of 1/2 is 0. Okay, so if x is 3/2, what is integer function of 3/2? 1, because it goes to the one below it. So since it's defined at this point, since there's nothing else, there's no hole or anything there, and if you look at the graph, what I actually have is, oh yeah, this, it is a piecewise function. So if I want the limit as x approaches 1/2, well, here is where x is 1/2, and clearly it's a piece on the graph there, and it is just 0. So substitution and graphically, it would look. Say again? Oh, yes, yes.
Hello, everybody. Why do you make that one? That was I like the little. Somebody else hot. If you just turn the fan on, it'd be good. What fan?
All right, say again. 0. It'd still be 0. Integer of 0.999 is still 0. Until you hit past 1, it doesn't go down. Okay. Okay, 3 and 4. Okay, so number 3 says find the speed of the object at t equals 3 seconds and confirm your answer algebraically. Yeah. Okay, but what is it approaching? Remember, you're looking at what it's about 96. Right. So remember, I'm looking at that f of x plus h minus f of x over h. Right? And you use 0.01 for h. Okay. Okay, so when I'm looking for instantaneous, so we're looking at IROC, right? So we're going to use this, and we're going to get our h as close to 0 as we can. And this says at time t, which t is really x here, right? So when t is, what did it say, 3. So I'm going to do f of 3 plus, and then here's where use one of your values that's really close. 0.01 or 0.001 or whatever it is. Or, and I'll show you algebraically after this. Let me go through this way. Yes. This is really like a table way of solving. To be accurate this way, you need to do 0.01, 0.001, 0.00001. Yeah, that's a way to solve it, and it's not wrong by any means. So, well, if you come up with that equation, I'll show you. I'll show you with the h still in it, where we factored out, where we FOILed it out, and then we canceled out the h, and then we plugged the value in there. But I mean, it doesn't matter. Yeah, and that's fine. Whichever way works best for you right now, because we're going to get into some quicker, easier ways of all of this really soon. So this is really f of 3.01 minus f of 3 over 0.01. And so if I plug that into, remember my f of t was 16t squared, right? So f of 3.01 would be 16 times 3.01 squared. Well, it's this formula is what it is. It's that equation formula, yeah. Does that make sense? Function, that's just like f of x. It's y. It is. It's really like f of t, yes. The variable's t there for time. And we said it approaches, what, 96 feet per second? Okay. Which other one did we say on your homework? 13? What?
These ones are easy.
So these, yeah, go ahead, man. I didn't mean to interrupt this. Go ahead.
Oh. First, what you're going to do is you're going to. Well, I just know that you're going to plug in -2 for x.
That's exactly right. When the directions say evaluate by substitution, you're literally plugging that value in for x. That's all you have to do. So this would be -2 minus 6 to the 2/3, which would be -8 to the 2/3, which is the third root of -8 squared. So the bottom is your root, right? Remember rational exponents? So what times itself 3 times gives you -8? -2. It's the third root. It's saying what times itself 3 times gives you what's under that radical. So what times itself 3 times gives you -8?
It would be 2, but -2 is -2. Nice. We do.
And then it said confirm graphically, right? So then I would go into my calculator. I had got to put the calculator. 13. X, whoa, minus 6 raised to the 2/3. Nope. My gosh, y'all stop. And so it was the limit as x approaches -2. So at -2, if you go to the point -2, you will see that it is actually -2,4, which is the solution. There are no other points on there. Because it's getting closer and closer to 2, see? It does. Even if it's defined there, it can still be the limit. That's fine. It works that way.
I can get it.
I think after today, it'll make a little more sense to you.
I can get it. Like, I don't really. But I can still read
What else? 15.
it. Does not exist.
I put that?
There's a zero.
Yeah, let me do 14 first. Yeah. I would definitely do that. Well, somebody else needed 14 real quick. So it's just substitution, so just like the other one, so it's the square root of 5. Okay. And then, of course, you could look at it on the graph and see that it gets to that same point. All right, so for 15, it asked you to complete the table, and I would most definitely be using my calculator for this. And in y equals, I would put the function, right? So the function for 15 is x squared plus 6x plus 2 over x plus 1. Okay, so the ones that are circled in gray, the ones that are, I always get confused. Numbers circled in gray are no calculator. So if it's not grayed out, you can use a calculator for it. This one is not grayed out because you're not going to be able to do that one without a calculator, right? That's a lot of. You are telling a story. I was going to say, you're going to have to, right. So, if it was me, I would hit y equals on my calculator, and then I would go second graph for the table. And if your table is not set up where you can type the values in, does everybody know how to change that so that you can? Go to uninstall.
Hello, everybody.
Okay, that's my goal today. I'm gonna fix my calculator on here. Yeah. Okay, so to change it where you can type it for the X, go second and whichever one it says table set above, TBL set. And then for independent, change it from auto to ask. All right, so hit second window. Second window. So that you can type the X value. So second window, and then change independent from auto to ask. And then go back in your table, and it should allow you to type in your value so that you don't have to just scroll through. Is that right there? So second graph again. That is an incredibly useful tool for the exam also because it will save you so much time. All right, so hit y equals and type your function, right? So here's my function. Just be careful as you enter it. You'll want parentheses here and parentheses here as you type that in, right? And then go, and then go second window and make sure beside independent that it says ask instead of auto. A lot of work. You don't have to show all this work. You know what I'm saying? Okay, so for 15, as you start putting in these values, you should see that it approaches and gets closer and closer to what? 2. So you're essentially finding the limit as you approach 0 on these, and it's 2. Did you go in your table and you do 0.1, 0.01, 0.001?
Wait, hold on. Actually, what's the answer to 17?
You're very welcome. That's okay. I'm gonna get you good with it. Yeah. 16? So 16 is the exact same way. 16, you're going to put in y equals, you're going to put x squared minus x over x. And then you're just going to go into that table and do 0.1, 0.01, 0.001, 0.0001 until you get, so you can see what it approaches. This is a strictly calculated problem. Grab that one off my desk right there, right on the corner. If you, yes, for sure. Yeah. All right, so go to y equals. Put parentheses, x squared minus x, close parentheses, divided by x. For 15, yes. Now, second. Huh? What about in the class? Okay. Okay, when you plugged in 17 and you did x sine 1 over x like that, and then you just went into the table, and what happens when you do, because you can't have 0, so we're getting rid, all of these you're approaching, we're looking at things where the bottom, the denominator can't be 0. So if you put 0.1,
You don't even really need to do all the math. You just need to plug this.
this means times 10.
Once you get off class.
So it needs to
I can bet they're fun to use.
Okay, so what this means? This means 8.3, but move the decimal left 4 places. So it's really 0.0008. See what I'm saying? All right, let's move on from this. Oh, wait, I just put in 0.1 for x. I didn't do it wrong. For which one? I think it approaches 0, doesn't it? Oh, does it? And you plugged in 0.1? It's 0.01. 0.1 times 0.1 would be, so remember you can't have 0.01. Yeah. That's where you messed up.
So is the answer for this one?
Van, how could you?
Dude, I tried my best. I don't know why I should get mad at me, but this is neat. You don't even need to do all this work. We can just put it in your calculator, right? So y'all, we're at
All right. Let's switch gears.
Wait, I still.
Same way. But, okay, so listen, on 17, as you start putting that in your calculator, you're going to start getting values like 2.3 e negative 5 or something like that. That is essentially 0 because it's 5 places to the left. 1, 2, 3, 4, 5 is what that means. Set straight on the calculator. Put them on the calculator and go into your table again. The exact same way. Say that again. I don't know because I don't have the answers in front of me. There you go. Okay. Let's do this. Let's keep our homework running for all of 2-1, and then whenever we finish this whole section, I'll take it all up at one time. Well, I'll do it however many nights worth it is. That's how many points it'll be worth. But make sure you're keeping up with it, you're correcting it, and you're doing what you need to do with it, because I'll look at it a little more closely. I think that'll be easier than trying to do it for each section. No, because that's going to be a calculator problem anyway.
Yeah.
Yeah. All right, let's switch gears and get out your notebook. Let's finish limits. Look, E with a negative number that follows it is really just 0 because it's telling you move the decimal place left that many times. You're doing all of that so that you can see what it approaches. I think that one's approaching 0. No, isn't it 9E negative something? Point 0, 0, 0, 0, 0. This is point 0, 0, 0, 0, 0. All right, more limits. Let's do properties of limits. Let's pick up where we left off. So I'm not going to redo those two we did yesterday because we already did them, or the first one. So we'll pick up. We did 1 and 2. We did 3 also. Okay. Oh, if you counted that one. Okay, I got you. All right, let's talk about the product rule. Y'all are salty. Just gonna throw that out there. On that.
I'm not salty. I'm ready to learn this.
All right, product rule, which is going to pair with the, guess what? Quotient rule. That's exactly right. So the product rule says if I have the limit as x approaches some value, yeah. I'll put them as separate. I was just running out of time yesterday. That's why I put 2 and 3 together. But I'll do these as separate. So the product rule says if I'm finding the limit of these two things, then I can split that limit apart and have the limit as x approaches c of f of x times, and these seem, and they are super easy. But they'll be super handy when you see how we're going to use them. A lot of these properties are going to be used with things like trig functions, where we're going to have to remember those identities and those cofunctions and things of the sort in order to evaluate the limit. Yeah. You got it? All right, let's do the quotient rule. Same thing. If I am dividing I can split them up into two separate limits. I'll do plenty of examples in a minute. Let me just get you all the properties here. Super handy property is our constant multiple property. This is the one that to me is not quite as obvious if you see it, but it's super handy to be able to do. If you have the limit as x approaches some value of a constant times anything, whatever it is, I can take that constant out and I can put it on the front and multiply the limit. So I can say k times the limit as x approaches c of f of x. And it makes sense if you think about it, because product lets me split up the limits, and the limit of a constant is the constant itself. So it makes sense why you could do it, but it's super handy to do it in just one little fell swoop there. This from yesterday. That was the addition subtraction. Yeah, it's because technically, remember that product property says that I could do the limit as x approaches c of k times the limit as x approaches c of f of x, and anytime I have just a value here, that simplifies down to just that value. And that's why. You don't have to write that down or anything. That's just the why to it. Yeah. So if I had, let's say I had the limit as x approaches 1 of 5x squared. I could rewrite this as 5 times the limit as x approaches 1 of x squared. And I could just evaluate this limit and then multiply it by 5 in the end. It's still, yeah. And again, we'll get into this way more complicated when we'll use this. We'll need to use this. Yeah, if it has a constant, yes. All right, so let's talk about how we're going to use these to evaluate limits. So this is where I really wanted to get through this yesterday and end up here, but we didn't. So, but it's okay. Huh? What other two words? Well, I counted the limit of a constant as one, and I didn't do the power one just yet because to me it's more confusing to give it to you than it is. It's something. I'd go to the next page because I got some examples embedded in this. All right, when we are given a limit to evaluate, and I should say algebraically, what process do I go through and how to evaluate that limit, and how am I going to solve it? How am I going to find what it equals?
That's a great question.
How is the new student?
I had two, so it's more like double what it should. And it wasn't as effective because I could better one on one.
Two.